Newton's laws of physics are torn apart as a new breakthrough fundamentally changes theories. It's concerning Sir Isaac Newton. A group of scientists believe that they have fundamentally changed one of Sir Isaac Newton's laws of physics, the conservation of momentum. We've all done this experiment in physics lab where you have those little balls hanging from strings and you move one and the middle ones don't move and then the last one moves, taking the momentum from the first one. Now in 1687, Sir Isaac laid down the laws of motion in Principia Mathematica, laws which have still held true over 300 years later. In the law of conservation of momentum, he noted that the momentum of a system would always remain constant, which means that when an object moves, it has to push against something else. However, in a new study, researchers found that the so-called fundamental law may not be universally true and could differ at least in curved space. By conducting experiments, scientists from the Georgia Institute of Technology in the US discovered that the opposite is true, that when bodies exist in curved space, they can move without pushing against anything. In a peer-reviewed study published in the Proceedings of the National Academy of Sciences, the team created a robot that was kept confined to a spherical surface with what they described as unprecedented levels of isolation from its environment. This was done to ensure that only the effects of the sphere would be in action. Lead researcher Zeb Rocklin said, "We let our shape-changing object move on the simplest curved space, a sphere, to systematically study the motion in curved space. We learned that the predicted effect, which was so counterintuitive, it was dismissed by some physicists, indeed occurred as the robot changed its shape. It inched forward around the sphere in a way that could not be attributed to environmental interactions. With a significant breakthrough, the effects observed in this sphere were extremely small, meaning that it likely would not lead to perpetual motion machines. However, this study on the effects created by a curved space could prove to be of crucial value in the field of precise robotics, similar to the time scientists discovered that gravity shifts the frequency of satellite communications." But this study ties into Einstein's research that shows that space itself is curved, which lead the team to believe that ultimately the principles of how a space's curvature can be harnessed for locomotion may allow spacecraft to navigate the highly curved space around a black hole. The experiment itself proved to be challenged, and as they examined an object in a sphere without exchanging momentum with its environment. To achieve this, the team allowed for a number of motors to drive on curved track in a system that attached to a rotating shaft, ensuring that the motors were always operating in a sphere. And in order to minimize friction, the shaft was supported by air bearings and was even calibrated with the Earth's gravity to further minimize any residual forces. The researchers discovered that as these robots moved, gravity and friction did exert forces on them, but they seem to have combined with a curvature effects to produce a strange dynamic with properties neither could induce on their own. They said the research provides an important demonstration of how curved spaces can be attained and how it fundamentally challenges physical laws and intuition designed for flat space. And this is on Express UK by Anthony Askenaz. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.